Hey everyone, and welcome back to another episode of CleanTechies, the podcast. This time we are at season 2, episode 7, or if you're counting from the beginning, we're at episode 19. Please do subscribe, click the bell to be notified, and leave us a review on whichever platform you're listening on. If you're watching on YouTube, feel free to comment below also your thoughts throughout the show. Just a real quick reminder as well, this show is sponsored and made possible by Next Wave Partners. Next Wave Partners are experts in the renewable energy, infrastructure, ESG, climate tech, and technology recruitment business industries. So if you are looking to grow your team or you're looking to take your career to the next step, please do reach out to Next Wave at info@next-wavepartners.com, or go to the website and reach out to a consultant that is within your remit. You can go to the team section of the website and find somebody that is within the remit of what you're looking for. So you can find them at next-wavepartners.com and then reach out to them there. So with that, let's get into the details of today's episode. I was very, very excited to have this episode today with Josh Santos, the founder and CEO of Noya. And in short, what they're doing at Noya is they are basically retrofitting cooling towers on buildings to capture carbon, which can then be sold to organizations that use carbon. So the specific companies that offtake the carbon is not a specific type of company at this point, just kind of anybody who uses it as they get going. But they have a really, really bright future ahead of them. So very interesting tech, and what the models that they have for creating this, the business models right now at the moment at least, there's no upfront cost to install these. So it's a really interesting thing that a lot of companies can do. Obviously, I think the biggest thing is just for making sure that companies can just kind of figure out a way to integrate this into their operations. Obviously, cooling towers are a very vital part to a lot of operations. So very interesting stuff with Josh. But without any further ado, let's get into the show. All right, welcome to the show, Josh. How's it going today?
It is fantastic, man. Good afternoon, and thanks for having me on the show. Excited to be here.
Absolutely. I'm very excited for this too. I think this is going to be a great episode. So I guess just for everybody listening, first of all, why don't you just give a quick background on yourself and how you ended up where you are now?
Well, yeah, would love to. I'm the co-founder and CEO of Noya. Noya is working to transition the world to a carbon negative existence. We're doing this by retrofitting existing pieces of industrial equipment like cooling towers and turning them into CO2 capture machines. My background's in chemical engineering. I studied chemie at MIT as an undergrad, and then I went off to do sales and business development at a YC-backed startup called Labdoor that does chemical testing for dietary supplements. And then pivoted again and went into EVs after that. I went to Tesla first and then to Harley Davidson. Before starting Noya, I feel really fortunate to be in the position I'm in because I, growing up, had to live through many different types of climate. I don't want to say disasters because that sounds alarmist, but things that may have been better had they not happened. Many hurricanes. I went to 13 schools across the Southeast before going to college, and lived through many hurricanes, had to go into the closet many times to hide from tornadoes from those hurricanes, just like bad memories that I would love to help other kids never have to experience. And so that's what really got me into sustainability and clean tech generally with EVs, and now into more of a climate focused role with Noya.
Awesome. Very good. So this is always to me an interesting topic of how people kind of evolve through their careers and get into what they are. So what were some of the main points along that journey that kind of led you to change to EVs and then to change to this role and to launch Noya?
Yeah, the first big change, I guess, that I've made was from doing purely technical work as an undergrad and sort of preparing my mind to be full-time engineer after graduating, to moving entirely away from that and doing strictly business stuff, quote unquote, as we called it when I was in college. We used to have these conversations like, oh, are you going to go and do like more engineering work? You're going to do business stuff. And a bunch of engineers that knew nothing about what it was like to have a job. It was all business stuff that was non-engineering. So I went to do business stuff. And so that was one big change. And the reason I made that change was because, I really wanted to, I knew that in the future I wanted to have this balanced skill set that had a technical foundation, but also was focused and experienced in doing business stuff. So that was a big reason that motivated just the switch from technical to non-technical, and then to go from sort of a sales, business development, startup focused role to something very different. I was doing project management at Tesla on the Model 3 program and helped lead some projects that helped increase production of the Model 3 and decrease per unit costs. That's a very different world than working at a startup, right? It's production heavy, huge pieces of manufacturing equipment, many different units, every second matters, the line shall not go down for any reason. Very different role. And I really wanted to do that because I knew that if I was going to do anything related to climate and sustainability, I needed to learn what it was like to be in a manufacturing setting of some sort. And Tesla is great because it's a fantastic mission, obviously, very mission driven, fast growing. It was an amazing experience and had a great time. Had some of the best people that I've worked with so far were at Tesla. So I'm fortunate to have had that experience and to have continued to kind of seen the inside of that. And Tesla operates very much like a startup in many ways, so that was kind of cool too. And then to go from Tesla to Harley Davidson, where I was the first program manager in the company's newly formed EV division, that was a whole different era, right? It was much more focused on learning what a 100-plus-year-old company was on the inside, how it operated, its tendencies and culture and behaviors and things like that. And I've been riding motorcycles since I was 15 years old, so it was a cool way to mix purpose and pleasure as well. So I think each sort of switch, each step has been motivated by a key part of my learning or education or knowledge that I just didn't have and wanted to gain. And as it so happens, the three experiences each contribute something unique to what we're doing now at Noya.
Yeah, to me, this is interesting because you have a probably very interesting perspective because you've moved through those roles. And this is something I've noticed a lot is with climate tech solutions. It's not easy because typically there's going to be some product involved, right? There's manufacturing involved in most situations, right? There's obviously some of the technical only solutions or tech only solutions, but that's very interesting. Did you recognize that at a young age and then kind of say, hey, I want to get into this? Or was it just kind of by happenstance that you ended up in those roles and then you realized, oh, this is great?
Yeah, many of them were opportunistic, I would say. When I was little, I had this tendency to go deep into rabbit holes. I think I freaked the librarians out, some of the elementary schools I went to, because I'd go to the library and check out all of the alien-focused books and then pound through them in a week and then return them, probably looking a little more alien. So it's amazing that I didn't get sent to some, I don't know, some special place. But growing up, I had these tendencies to go down rabbit holes, and that's kind of how I behave now, right? As a grown up, or somebody who's pretending to be one, at least, that I become really interested and excited and obsessed with an idea and just dig into it as much as possible. And I would say that's kind of what led me to Noya, right? I think that it's just sort of this natural evolution from being interested in doing something good for people, which is what we were doing at Labdoor. We were testing dietary supplements by buying them off the shelf and running chemical tests on them to tell people what's inside of them. That's good for people. And then going to Tesla and helping make the transition to a more sustainable means of transportation and energy. That's great for people and great for the planet. So that's another check mark there. And then going to Harley Davidson, where we had been doing products for years, right? Harley it's like a well-oiled machine when you talk about the ability to go from idea to implementation. And so sort of seeing that entire life cycle and the evolution of impact. And I think, as I was in one role, right, I sort of understood and learned like, oh, this is a set of experiences I don't have, which I didn't know I didn't have before taking this role. So I think that each experience helped me see the thing that I needed to be doing next and what would ultimately be an accelerant to what I wanted to do in the future.
Interesting. So just a number of building blocks that kind of worked out well. That's interesting. I think that's exciting because obviously, a lot of people try to envision what their career is going to look like, but I think maybe people could take a lesson that sometimes you just need to follow a little bit of kind of maybe that altruistic spirit inside of us to help go solve another problem, right? So
Yeah,
very interesting.
Yeah,
Okay.
getting to your career goal is like climbing a mountain where you can't really see the whole mountain when you're at the base of the mountain. You kind of think you know how you're going to get there, but then you get halfway up and you recognize there's a patch of flowers where you didn't know, and you want to walk through that. So you do that instead. It's very much like that. Yeah.
Yeah. Yeah, absolutely. That's a good analogy. Um, okay, so tell us a little bit about, I mean, a lot about, let's talk a lot about the technology. I want to really understand kind of how this works, how Noya works. What exactly do you do? Just let's dive in.
Yeah. So our carbon capture technology relies on retrofitting existing pieces of industrial equipment called cooling towers. If you're unfamiliar with cooling towers, you can basically think of them as a big box inside of which there's a fan that's spinning to pull air up and inside of this box. And there's a shower system, sprinklers, water distribution devices, whatever you want to call them, that's dropping water down on the inside. So you have air being pulled up with this fan and water being sprinkled down with these nozzles, and the two are physically coming into contact with each other inside of this box. This happens sometime on a corrugated material called packing material. Sometimes it happens on top of a series of sort of these tubes that carries a hot fluid. Either way, these things are touching each other to harness the power of evaporative cooling to cool some sort of process down. So these cooling towers are making air and water meet in the middle to dissipate heat that's brought into the cooling tower from some other part of some industrial process. So picture our piloted facility is a great example. They run, it's a dairy creamery. They bring in milk from all of the cows around all of their farms in Northern California. They run that milk through pasteurization equipment where they add heat to pasteurize the milk. The pasteurization equipment has to get cooled, so they run water around jackets that are on the outside of the equipment. That hot water that's cooling the pasteurization equipment gets sent to their cooling tower to cool so that they can run it back to the pasteurization equipment so that it can carry more heat outside. So it's basically this thing used to dissipate heat. What we're doing is we're taking a blend of clean CO2 capture chemicals that we've been developing over the past year plus and add it directly into the water used by these cooling towers. What that creates is it creates now this water that has these chemicals inside of it, meeting air that contains CO2 inside of it physically. CO2 naturally wants to dissolve in water. If you've ever had a carbonated drink or a liqueur like I'm enjoying here on the side, then you know that water carbonates. And so as that CO2 dissolves into the water, it reacts with the capture chemicals that we add into that water and gets stored as a chemical intermediate and allows the water to capture more CO2 than it otherwise would be able to. And so we're converting this water into a carbon sponge. Every sponge that's wet has to get squeezed if it wants to absorb more water. Our squeezing, in this case, is the equipment that we install alongside the cooling tower. So we install equipment that, using a combination of heat and pressure, regenerates the captured CO2 or releases it from its captured state in a very pure form, which we then pressurize and transport offsite for sale and removal. And so that's sort of how the process works. We use cooling towers to bring air and water into each other. We release the captured CO2 using other pieces of equipment we install. That gives us a pure stream of CO2 that we can kind of do whatever we want with.
Wow. That's very fascinating. The fact that this actually works, the fact that somebody, well, you guys and whoever's developing this, right, have come up with this is quite incredible to me. I wish I went to school for engineering maybe a little bit right now. So, okay, this is very interesting. So maybe walk us through maybe the installation process, or kind of how does it work to set it up? Obviously, maybe continue with this example of the creamery. Like, what was the process like? Just very curious on that whole setup.
Yeah, the I think one of the most exciting aspects of our process is the fact that because these cooling towers already exist in huge numbers in the country, there are 2 million of them in operation today in the United States. Because they already exist in huge numbers, we can keep our upfront capital requirements and the time that it takes to actually build these things incredibly low. So from the time where we sort of signed our pilot deal to the time where we actually had the process installed at this place. I think overall it was about 4 months before we first produced CO2 from this facility. We did that with a team of less than 5 people, and we did that for a few $100,000. So our process is incredibly low cost, incredibly fast, incredibly scalable to build, because all we really have to do, and this is the first one that we had to do, right? We had to design the specific pieces of equipment, which we've now done, so that gets easier in the future. We had to spec out the specific amount of chemical blend that we needed. That's also been done now, so that goes faster in the future. And then we had to actually install it, which we've also done once, so it's also going to go faster in the future. So I think everything that we did then was a nice startup-like experience in learning things you didn't know you needed to learn, and it involved a lot of us, everything from carrying huge pieces of stainless steel on our backs to like needing to strap a 900-pound piece of equipment suspended in a certain way so that we can seal the middle flange correctly, like all kinds of kind of crazy stuff. This is very, very industrial like installation that happened. But yeah, I would say like big chunks were design, procurement of the equipment, and then actually installing it. And now we're in the process of bringing it up and testing it. We know that we can produce CO2 that's above a 90% purity, and we need to get that to be 99.9. And we are in the middle of getting that gap closed right now.
So in closing that gap, is that mainly just kind of refining the chemicals used, or is there a little bit of fine tuning the equipment itself, and maybe making sure that everything is hooked up properly?
Yeah, I think it's a little bit of all of the above. We've had situations with our prototype and this pilot where we just had an air leak, and we had to find where the air leak was. Sometimes these solutions to the types of problems you see in industrial startups are probably the least sexy thing you can imagine. It's like I got air coming into this pipe. I don't know how air is coming into this pipe, but I got to throw some goop onto this hole so that no more air comes into this pipe. It's very much that
Exactly.
kind of stuff. I feel like I'm channeling the original Industrial Revolution vibes a little bit, because I'll go into the office and I'll be wearing like a button-up shirt, like a normal person would, and then I have to go to site unplanned, and then I leave and I'm just covered in dirt. It's very much a dirty sort of thing, but it's a ton of fun. It's very hands-on, and those are the most gratifying projects where you literally put sweat and tears and sometimes a little blood into them, and you turn it all on, and you're sweaty and you're nasty and maybe you're bleeding a little bit, but it works, and the thing actually produces what you want it to. And in our case, that production just happens to be something that the world needs as well.
Exactly. That's great. So let's talk a little bit more about in regards to implementation. How does the financing work for your clients? Is it typically upfront cost, or maybe those things being developed? I'm really curious always when I talk to people in the climate tech space that almost always, I've seen it almost every time, that these technologies are really a no-brainer because they are ROI positive very quickly, or they maybe even reduce costs in the immediate future, in the immediate timeline. So talk about that a little bit.
We've tried to be as no-brainer as possible as well. The best solutions are the ones that make financial sense, at least for companies, and if it works for the world, great. And that's exactly how we've tried to model it. We are offering the installation of this process at no cost to the companies that own the cooling towers. So if you have a cooling tower and you want to have this process installed, and in the process of running this carbon capture device next to your cooling tower, you actually get paid. And so that's sort of the way in which we've done it. The model is that we cover the upfront capex, we take the CO2 that's generated and we sell it, and we give the companies we install with some small percentage of the revenue that's generated through the sale of that CO2. From their perspective, from our partners' perspective, they pay nothing and get paid. It's sweet. We're turning a cost center into a profit center for them and giving them a fantastic story to tell at the same time. From our perspective, it's also sweet because we get much lower cost of CO2 captured from the atmosphere and a much smaller amount of time to do that than we otherwise would. So we've built this very synergistic model that works with people that have these pieces of equipment, helps us keep our costs low, helps them make money, tell a great story. And we found some great response to that.
I feel like I'm guessing that your experience in doing the B2B sales has really helped in making sure you understand, okay, what are the objections going to be, and just getting rid of them all. Like there's no reason for somebody to be like, oh, I can't afford it, can't do it. So I think that that's very brilliant. I love to see it when it's done this way. I know I think it's not typical. Maybe it's becoming more typical to do business this way, but it used to not be that way. So I'm excited to see that. I guess generally, I'm curious about the other. Maybe if there was an option in the future with that model, could clients decide to pay for all the upfront costs and then be the person who actually owns all the CO2, and they can decide to sell it? Maybe there's a marketplace for that you create in the future, or maybe there's already one. Just curious, like if that's an option too.
Definitely, we've thought about how to give the partners that we work with the freedom to operate the equipment and use the CO2 however they want. I think the model, which you just said, is one idea we've thought about. Another one that we've thought about is that they, is the model where they also consume CO2. So you can think of this integrated on-site production and consumption of this commodity that is very common and exists thanks to the Big Bang universe thing, all these years ago. And so, yeah, we've thought about a lot of this sort of like keeping this model very contained and self-centered. And we would love to offer that to people in the future when and where they're interested in it, and would love to sort of provide like this playbook on how to operate the equipment and what needs to be done and that sort of stuff.
Yeah, I can imagine. I can imagine there's so many things you want to do. It's just a matter of focusing on what you do best at the moment until you've gotten to that point, and then you can easily begin to implement more things. So it's probably an exciting, but also maybe slightly frustrating part of the gig. I'm curious, maybe a little bit. I'm assuming there's multiple uses, but where does you sell the CO2? What is it typically used for? Are there typical use cases that you anticipate or that are already being used? I'm very curious.
Our ideal use case is one in which the CO2 gets locked up and removed from the atmosphere permanently. There are a couple of options that allow for this right now. You can think CO2 to cement or CO2 to diamonds or anything else really that results in that long-term lock-up of carbon. Carbon's a natural building block, right? It's all over the world and almost everything around us. It's not bad. We have just sort of painted it in this bad light. Carbon itself is incredibly valuable and something that's core to us. And so if we can find a way, or if we can find a partner who's taking that CO2 and locking it up in some other useful, valuable thing, we'll always do that. Same goes for sort of removal credits and the generation of those. We haven't talked about those yet, but that's something like that we're also thinking about, like how do we relate to credits and how do we relate to that? And so where there's a market for removal credits, we will also do that. But lacking those two things, because they're growing and becoming more consistent, but aren't yet to that point, we will sell it just to people that consume CO2. So think small businesses in food and beverage, research laboratories, medical use cases, semiconductor use cases. There are many use cases that CO2 is used for in today's industry and the way in which we function as a society. And we're producing the same CO2 that's used in those cases, except ours is the cleanest source of CO2 you can find. Many other sources of CO2 come from ethanol, and ethanol is mostly made with corn. And so if you backtrack the related emissions that are not related to the actual CO2 you're buying, but emissions that had to happen to get to that CO2, right? Land use, harvesting, transportation of corn, breaking down of corn, all of these types of things. That adds up to a significant sort of related emissions for 1 ton of CO2. For us, our ton of CO2 is carbon negative, right? We're pulling more CO2 out of the atmosphere than what we're producing. So we do provide the cleanest source of commercially available CO2 that you can buy in the United States right now. And many people are excited about that.
Yeah, because it's not only solving a problem for your clients, but it's also solving a supply chain issue in general, right? This is something I'm excited about, is all the companies that are that are being created and that are doing things to actually clean up the supply chain at large. You mentioned something that I did want to touch on, which is the carbon credit. So I'm curious what technologies are already in place, or maybe will be in place soon within what you're doing, that are able to very transparently track the data on how much CO2 is being removed. Because I know that with the entire ESG kind of sustainable development goals that are happening, we want transparency for everybody. We don't want greenwashing. So are there already data collectors in place to actually show, hey, this is what's being done? So that way that company, that's a value add to them to now say, okay, we can show and
Yeah.
verify that we're tracking these things. What is that looking like?
Yeah, our process will have both that and energy tracking to, I guess you need energy tracking for carbon tracking, but I'm distinguishing between the two because energy tracking is important for the partners that we work with. Those folks are going to be the ones getting charged for the electricity that we use since it's their building or their facility. And so we're going to want to track that separately so that we can pay them back for that. And that's the plan there, is that we compensate any incremental operating expenses that they might face by running our process on their cooling tower. So we'll take care of that for them, and that's why I broke it out differently. But we'll also need to have carbon tracking as well for everything you just said. And it'll take into account a combination of energy consumption with the grid mix for each individual location, plus just CO2 production numbers, which we'll be able to distinctly measure based on flow rates and pressures and these sorts of things. So flow rates of CO2 and pressures of CO2, I mean. So all of that's going to be tracked within the system that we're developing. We're also going to integrate into that emissions due to transportation, right? Because we have to move CO2 around. So we're going to want to keep a close eye on that too. So all of that's going to be over in the we're sort of envisioning this dashboard, like I'm picturing being like a NASA mission control type center, where you have this huge screen and like a picture of the country on it and a bunch of flashing dots with like data popping up and down everywhere. And like all of those dots are CO2 capture sites with cooling towers running on them. And you can see information about any single one of them. Any single one of them at any time. So that's sort of the vision, and that's where we're moving and heading to, and we'll implement different versions of that as we get further along in development.
Yeah, that makes a lot of sense. What have been some of the biggest challenges, and what have been some of the biggest challenges and objections potentially that you have faced?
The biggest common objection that we faced when talking to partners about this is how our process integrates with their equipment. Many of these people that own and operate these pieces of equipment do not always want things to be changed about it. They don't want new things to be changed about the water chemistry or new pieces of equipment to be installed next to it or anything else, because in some use cases, these cooling towers are very critical components to the rest of the overall system. In some cases, they can be potentially single point of failure across the whole system. So they're incredibly important, incredibly critical, and depending on the industry, many people that we speak to are understandably very risk averse, right? They don't want to try new things out. They just want to keep things moving in the way they have been so that nothing breaks and the process keeps flowing. So that's been the biggest objection consistently. And that's exciting because we are working around that in many ways. We're obviously testing with our pilot, right? And we take data samples and measure water content and whether anything's in there that shouldn't be. So we do that kind of measurement to make sure that we're not adding anything weird into that water, and ultimately giving the company a good peace of mind with the fact that they're running our process. That's one thing. The second thing is that we're working with external partners that make this equipment, these cooling towers. And we're in talks with them about the process and looking at potential partnerships there that will help us show in a way that will provide more credibility than if we were to do it ourselves, that our process is safe to install alongside these very important pieces of equipment. So we're working at it from two angles, and the longer that we go on in time, the more data we can collect and the better off we'll be for telling that story with at least some numbers behind it.
Yeah, exactly. And the more use cases, then it's more easy because not everybody is I mean, we talk about individuals on the adoption curve, right? But imagine companies who are filled with individuals. So you have to have a pretty good number of them being interested in being early adopters. So that's interesting. What have been any maybe unexpected wins or things that you didn't see coming that just been like, wow, this is great?
Yeah, I mean, the biggest thing that we're really excited about right now is that with the build and development of our first process, we've learned, first of all, we've learned a ton about just the science behind direct air capture and why it's so hard. And we can probably do a separate podcast just on that. It'd probably be really boring. It'd involve a lot of words that are like, you know, chemical in nature and might be better as a lecture on a whiteboard. But we've learned a ton about that. But through the process of doing that, we found that there are many different specific embodiments of the carbon capture process that we've developed that if you could change a couple of different things, you might open up this process to many other walks of life, many other pieces of equipment, many other areas, locations, and therefore much more CO2. The thing that gets me most excited specifically is the fact that we're currently working on developing a version 2 of our process. I can't tell you too much about it right now, but what I can say is that it moves to take some of the best characteristics of our version 1 as it relates to how we're tapping into the cooling tower and what exactly we're using, and capture CO2 using just those things. And I'll give you one example because you're probably like, what the hell does that mean, Josh? That's super vague and confusing. We're looking at how might we be able to use just the moving stream of air that moves out of the top of the cooling tower to capture CO2 instead of needing to do anything with water. Let's go forward in time in the world where that actually becomes something we've achieved, which we're really close to having our first proof of concept done right now. Then there are many industrial use cases that have just moving streams of air with no purpose.
A lot.
Many. And so we then become open to all of those use cases. We become open to residential use cases where every single AC unit next to a house in all of the suburbs of the United States become individual little carbon capture equipments. We then move on to, can we get onto moving pieces of vehicles, like moving transportation units? If I put this on a train and a train's moving forward in space, can I capture CO2 just by being there? So it becomes incredibly exciting to think about how we can apply that type of technology to many other kinds of applications in the world, because we've built a lot of stuff over the past 100 years. And if we're going to get out of this problem in the next 30 years, then we should take every opportunity we can to use all of that stuff to help contribute towards the solution of this problem. And so that's what I get really excited about, that I really wasn't expecting when we first started this company, but something that we are thinking a lot about right now.
Yeah, I think that's a good point you make. I mean, you could talk more about this, but generally, you've probably seen being in the space and going up maybe against a lot of the thought leaders. You know, you talk about there being many ways we can try to solve the problem. Have you, what are your thoughts in general? I know there's a pretty big consensus out there of some people thinking, oh, well, this is the way we need to go about it. This is the way we go about it. Because obviously, from my perspective as a more action-oriented person, there's been a lot of thought that has happened, right? A lot of thought and sometimes not enough action, right? So like, could you comment on that in general, just kind of that mentality in the industry?
Yeah, absolutely. I think that there's a lot of I think Chris Sacca from Lower Carbon Capital called it green on green crime, which which is people that are passionate and working in climate trashing other people who are passionate and working in climate because they may not agree that the solution the other person's working on is the one we should be working on. And I think it's really unfortunate to create that sort of like inter-team rivalry, right? I picture it as if like we're gearing up for a sailing regatta. I just started sailing, so this is very top of mind. For gearing up for a sailing regatta, and then I punch a hole in my boat and say, good luck to us. It just isn't something we should be doing. And I think where it comes out the most, at least where I see it the most, because it's more relevant to me, is that people sometimes question the need for carbon removal and say it's overhyped and say that it's something that we should be spending little to no time on, because we need to be doing all of this electrification and energy efficiency work and emissions reduction work. And like, yeah, I absolutely agree that from an impact perspective, emissions reduction and every ton of CO2 we can not put into the atmosphere is going to have way more impact than having to pull tons out of the atmosphere to reverse that problem. I do not disagree with that at all. It's just mathematical. What I think, what I would encourage folks to think about, if maybe they stand on this, on that side of it, is that we are at the point where we need every and all solution we can come up with, right? We don't have time to be picking and choosing what the silver bullet is going to be for climate. There isn't a silver bullet. We have 2 trillion tons of CO2 in the atmosphere that we need to remove. No single silver bullet is going to do that. And so I think that we need to stop this this green on green crime, and just be welcoming and encouraging of all ideas and all people that want to be working on it. I think that if there's one thing that we should be doing, it should be saying we just don't have enough people working in climate generally, right? We need everybody working on this. This industry has to grow to be the size of the current oil and gas industry. That's a lot of growth, and it's going to require a lot of people. So rather than, I think, fighting amongst ourselves, we should be trying to encourage and welcome people into the fold to bring their expertise into the solutions that we're all trying to build together.
Yeah, I think there's 2 things that really come to mind when you mentioned these things to me is, first of all, it's the R&D process for any of these technologies is pretty significant, right? And maybe you could chat to that a little bit. How long did it take you guys from kind of concept to create and prove that?
From backyard prototype that got the bomb squad called on us, to commercial installation that is pulling CO2 out of the sky, we went, I think it took us like 15 months about, and that's for the first version of our process, and not something that will sort of scale and grow. I think we have some iterations to do on it, but that's that sort of first amount of time. Yeah.
Okay, well, that's pretty fast, actually. I was expecting it to be longer. That's pretty good. But just generally speaking, like when you talk about the people wanting one way or the other, I think that we have to remember too that we have to create the technologies we can right now, because there's going to be better technology that comes along, right? And we need to get to those base levels. It's just like, all of the startups that came out of tech and the internet in general, right? It was enabled by one thing coming along first, and then more things coming along and the other things getting out of the way. So that's interesting. But you also talked about we need more people working on it. So I'm really interested with what has your experience been throughout university, and then maybe kind of through the different roles you've been in, with the role between climate tech companies and education, because I know typically education systems like 2 or 3 years behind the times, depending on the organization. And I know that a lot of people going into university don't necessarily know what they want. So it's how can we help? How can that partnership happen better? Do you see anything happening? What has your experience been? Just really curious to hear your thoughts on that at large.
When I was at MIT, I think roughly 25 to 35% of the entire student population was in computer science. And that was a reflection of the fact that at that time, it was, sort of like another coming of tech, right? Facebook was becoming a huge thing, Uber, Airbnb, like all of the big tech companies of today were built around that time. And so people that were ambitious and wanted to, maybe had some entrepreneurial inkling to them, or whatever the case may have been, right? That's just sort of like what they were doing. That was the path. Those were the examples that were visible, and that's largely what a lot of folks did. The chemical engineering department was a fraction of that. I think there were 60 people in my graduating class total. Granted, MIT population is not big, right? There are 1,000 undergrads, but that's still pretty small. So I think that generally, if you're an undergrad that's trying to figure out, or you're about to be an undergrad and you're trying to figure out what to do and how to make an impact, consider studying something really hard, like chemical engineering or mechanical engineering, or aeroastro, or physics or chemistry. A lot of these hard sciences, these things that maybe were not as sexy, a few years ago, but are incredibly in demand now, because they're all needed to solve this climate problem, right? Another common debate that we hear is like, what's more important, atoms or bit to solve this problem from a software-based perspective and make things more efficient and run smoother and faster and better. We need that as well. But we also need things that are literally physical because it is a physical problem in nature. And so I think it's that side of the world that, just based on the skill set of what I think many people have focused on over the past 5 to 10 years, might be a little lacking at this point, and one that I think we need more emphasis in, and more people getting into.
Yeah, I think that's interesting. I mean, what I've learned through doing this show is that it seems like engineers who can learn a little bit of commercial acumen are the ones who own the future. I mean, they're the future owners of these big companies, and they're like changing the world, right? So I think that I always try to encourage engineers I work with in recruiting to just explore a little bit more of that commercial side and maybe be those people of change, because we need them, right? And I think that there's a tendency maybe to have them undervalued, at least currently. I think that will change. Um, but yeah, that's interesting. A couple other things, just curious about, what is your thought? Maybe there's some things already happening in the role that regulation plays in helping to get companies to start adopting this technology quicker. Because I feel like you guys are probably just slightly ahead of the curve on that, is my gut feeling.
Regulation is one of the things that would most accelerate, I think, the carbon removal industry generally. And there are many ways in which that could happen, right? Regulation could come in the form of incentives. It could come in the form of penalties. It could be both. And I'm definitely not. This is outside of my area of expertise, so I'm not going to even pretend to talk intelligently about it. But what I will say from my own experience is that we've seen a large amount of building owners, which is where we're first targeting our technologies, commercial properties. Large amount of building owners who have a mandate from a given municipality or locality, like New York City is a great example, that have regulation now that they have to meet that regulates their carbon footprint and gives them a ceiling. And what it does is it just starts the conversation, right? It makes these companies have to consider their footprint and have to consider how to lower it. So that's great for us because our solution can help them lower that. And it just so happens to come in a low to no cost to them. So that, in that sort of one example, in this one fraction of the universe, this one sliver of the universe where regulation has happened amongst this small segment of the population, then yes, it is an accelerant, and it helps people. It can help significantly move the needle on reducing carbon emissions and overall carbon footprint of given set of companies. Now, what does that look like on the federal level and on the state level? And, if you sort of like expand that out, again, outside of my wheelhouse to speak intelligently on, but from my own perspective, as somebody who is working to build a company in the space, I've seen what policy can do when it's thought about intelligently, and how much it can truly help the adoption and installation of these types of solutions.
Yeah, I think, to me, one of the things I've noticed that seems to be pretty valuable is just educating the lawmakers on it, right? Sometimes they just need to understand what's going on, right? And I think that especially solutions like Noya, where it's a ROI positive, especially if they follow the model you have already, right? They're going to be making extra money from this. So it's an actual no-brainer to do that. And I think it's a different story when you're telling somebody they have to retrofit their whole building and it's going to cost them loads of money and it's not going to save them anything. Then it's hard to swallow. But at the same time, we all need to do it. And I think it's important. It's just always the tough part of, at what point do you cap it? Like, because you don't want to make it hard for new technology to come in, et cetera. But interesting. So maybe just to kind of wrap up here, any final thoughts, or just the future? What are you excited for in the future, whether that's specifically with Noya or climate tech in general? What are you looking forward to?
I am so excited about all of the new types of solutions and companies that are cropping up every day, right? It seems like every day there's a new company coming out of stealth or launching a new product or doing something that gets me really, really optimistic and psyched about what the future is going to look like, right? We have this entirely transformed grid that's running to zero carbon, zero net carbon, that's powering all of these new types of technologies that rely on that clean electricity. And we have this distributed network of carbon vacuums that's pulling CO2 out of the air. And there are all of these people that have this new these new voices and this new sway and influence in this new world, because we realize that environmental justice is something we need to be doing. So we've done that, and now people are have a voice in that and haven't been left behind. So there are just so many things that get me psyched about the future based on what is happening today in climate tech. And I'm not talking about like the amount of capital that's coming into the space. That gets pointed to a lot, and that is exciting. It's really exciting to see how much investment is flowing into climate tech. But I'm talking strictly about imagining the world where, let's suspending full disbelief, right? Just imagining where everybody is successful. All of these cool ideas and companies are successful. What does that world look like? And when I think about it, that is an incredibly exciting world to live in, and one that I hope gets here as quickly as possible.
Yeah, it must be exciting to be somebody at the front end of helping make that possible. So that's great. Awesome. Well, I really appreciate you coming on the show. We will definitely have to see you on next time once you release these new products and kind of continue to advance. But awesome. Thanks so much, Josh, and we'll see you next time.
Yeah, no, really, really appreciate the invitation. Thanks again for having me, and it's been a blast. I had a ton of fun.
Thanks so much for joining on today's episode. Really hope you found a lot of value and enjoy the conversation with Josh today. Definitely, to me, again, this tech is so interesting. If you have any questions, feel free to reach out to him through LinkedIn. If you have any questions that you want to follow up with on the next time we have him on, feel free to reach me through Twitter at Silas Maynor. You can also reach me through LinkedIn. I'm very active on LinkedIn, so feel free to reach out to me there. Share your thoughts. Definitely, if you're part of the Slack channel too, we can start a discussion there. Always glad to take it one step further. And then, we always ask that you please do send this across to a friend, share it with a friend that might find value in kind of what Noya is doing. If it's something of interest to them, please also, if maybe you're in a space that this is just a generally interesting topic, please share it with your networks, as that helps us to grow the show. So another thing to mention, as always, is please do consider subscribing to the newsletter, which comes out on the 27th of every month. So that's upcoming in the near future here. We're actually going to be this month in September talking about air quality. So kind of related to this topic a little bit. Obviously they're capturing carbon out of the air, but generally an interesting topic. So you can subscribe to that. If you are not already part of it, become a member of the Slack channel by going to the link in the description to take the discussion further to meet with other climate tech and clean tech professionals, as well as just enthusiasts, people who are learning about the space every day. And you can also support the show by going to the Buy Me a Coffee link in the description. It's buymeacoffee.com/Silas Maynor. And yeah, if you have any other questions, feel free to reach out. We really appreciate your support of the show, as always. And we'll see you next time on CleanTechies, the podcast.